All right, let's talk about something that I know keeps a lot of engineering teams up at night. How on earth do you actually test modern, complex, distributed systems? The old playbook just doesn't work anymore. So today we're going to build a new one, and it's all based on a totally different way of thinking about quality. Let's get into it. I mean, we've all been there, right? This is the question that haunts our nightmares. You've done all the testing. Everything's green across the board. You push to production, feeling good, and then, boom. Something totally random and unexpected just falls over. This isn't just a string of bad luck. It's a huge red flag that the very nature of failure has changed, and our testing strategies desperately need to catch up. So, to figure out the solution, we first have to really, truly understand the problem. The thing is, we're operating in a completely new world of failure. All the old rules about how software breaks, they just don't apply anymore. Moving from those big, single monolithic apps to a world of distributed microservices has completely rewritten the rulebook. Yeah, just look at the contrast here. It's night and day. In the old monolith world, failures were, dramatic but kind of simple. The whole system would just go down. You could usually predict it, and it was easy to see what went wrong. But now, oh man, failures are sneaky. They're partial. One little service gets a bit slow, and suddenly you've got this domino effect tipping over the whole system. They're non-deterministic, which is just a fancy way of saying you can't reliably make them happen again, thanks to things like network weirdness. The enemy isn't one big bug anymore. It's this weird, emergent behavior that comes out of the whole system working together. And this new world brings a whole new cast of villains we have to learn how to fight. We're talking about things like partial failures, where one little piece of your system is sick but not totally dead. Network partitions that just chop your services off from each other. And my personal favorite, these cascading slowdowns, where a tiny bit of latency in one corner of your system creates a massive tidal wave of timeouts everywhere else. It's a mess. So when you look at that new reality, it's really no wonder that our old testing models are completely falling apart. I mean, the tools and the mental models that we used to rely on to feel confident, they're just not built for this new chaotic world. And here's exactly why. For starters, our traditional tests are built on the idea of a predictable, orderly world. That world is gone thanks to network calls and async events. Second, they're always looking for a big, total failure, but the real monster hiding in the closet now is the partial failure that leaves your system in some weird, inconsistent state. Third, just do the math. The number of connections between services grows exponentially. Trying to test every single one is literally impossible. And finally, that pristine staging environment you've spent so much time on, it's basically lying to you. It can't ever truly replicate the scale, the weird traffic patterns, and the chaotic timing of real production. Okay, so if the old way is broken, what do we do? This is where we need a completely new way of thinking. This is the big aha moment. We have to stop thinking about testing as just, a brute force activity and start thinking about it like a strategic investment. Just let this one sink in for a minute. Testing is not about volume. It's about signal. Running more and more tests doesn't magically make your system better. A lot of the time, it just means more cost, more flaky tests to maintain, and slower feedback for your developers. The goal is not to run a million tests. The goal is to run the right tests, the ones that give us the clearest, strongest signal that we can actually be confident in our system. And this leads to the core idea. We have to treat our testing efforts like an investment portfolio. Think about it. You wouldn't put all your money into a single high-risk stock, right? No, you diversify. You carefully allocate your resources to get the best possible return. For us, that return is confidence. We need to invest our limited time, money, and energy into the testing activities that give us the biggest confidence yield for our buck. So how do we actually structure this portfolio? How do we put this idea into practice? Well, we can use a model that many of you have probably seen before, but we're going to look at it through this new portfolio lens, and that's the microservices testing pyramid. We're going to build this thing from the ground up. At the very bottom, the foundation, we have a massive base of fast, cheap unit tests. This is our safest, highest return investment. They're great for making sure our core business logic is solid. Moving up a layer, we have what I think is the real game changer for microservices: contract and component tests. These are amazing because they make sure services can talk to each other without having to spin up some huge, slow, expensive integration environment. Above that, we get way more selective. These are our integration tests. They're a reality check on a few critical workflows between a handful of services. And then, way up at the tiny little peak of the pyramid are the big, expensive, and often flaky end-to-end tests. We use these very, very sparingly, only for the absolute most critical user journeys. That's it. Now, the pyramid is a fantastic strategic map, but it's just a map. It only works if it's held up by a few really powerful modern engineering practices. These are the three pillars that make the whole thing stand up. The first, and honestly the most important pillar, is contract testing. This is the absolute backbone of a healthy microservices testing strategy. It is the thing that lets different teams move fast and work independently without constantly breaking each other's stuff. And the way this works is just genius in its simplicity. The consumer, that's the service that uses an API, creates a little file called a contract that basically says, hey, here is exactly how I use your API. These are the fields I need. This is the data I expect. That contract gets shared, and now the provider, the API itself, runs a test on every single code change to prove they haven't broken that agreement. It's like an early warning system that catches breaking changes before they ever even get deployed. Okay, so contract tests are incredible, but what if you need to test a real workflow, and the service you depend on is flaky, or maybe it hasn't even been built yet? You can't just sit around and wait. That's where our second pillar comes in, service virtualization. Just look at the difference here. Without virtualization, you're stuck, you're blocked. Your tests are unreliable and flaky because you're depending on other unstable systems. And good luck trying to test what happens when something goes wrong. But with virtualization, you can just simulate those dependencies. Your tests suddenly become rock solid and repeatable. And here's the best part. You can program the failures. You can tell your virtual service, hey, for this test, be really slow, or return this specific error, so you can prove that your own service handles it gracefully. All right, on to the third and final pillar. And this one requires us to accept a fundamental, kind of radical truth. The only test environment that truly 100% matters is production itself. We have to become production aware. Now, I know testing in production sounds terrifying, right? But we do this in a very controlled, very scientific way. We use things like Canary deployments, where we release a new feature to just, say, 1% of our users, and we watch the metrics like a hawk. We use error budgets, which are based on our reliability goals, or SLOs. If our error rate starts creeping up, the rollout gets automatically stopped. And we use our observability tools, all those fancy dashboards with metrics, logs, and traces, as an active testing tool to validate that our system is behaving correctly under the chaos of real traffic. This whole mindset reaches its ultimate conclusion with a practice called chaos engineering. This is where we go from just passively watching production to actively experimenting on it. We deliberately inject failures. We literally crash a server on purpose, or we introduce network lag, all to prove that our system is resilient and can handle it. We break things on our own terms so they don't break by accident when we least expect it. Okay, so we have the pyramid strategy, we have the three pillars supporting it. The final, crucial step is to put all of this on autopilot. We build these layers of testing directly into our CI/CD pipeline, and we turn that pipeline into an automated, intelligent, quality gatekeeper. Just follow the journey here. Every single time a developer commits code, it runs through this gauntlet of checks. It starts with the fastest, cheapest tests, our unit and contract tests, for instant feedback. If those pass, we move on to the more involved integration tests. Only after that do we run our very few, very precious EDE tests. But the final gatekeeper, the final boss, is production itself. The Canary deployment has to prove with real user data and real health metrics that it's safe before we give it the green light for a full rollout. Quality isn't just a checkbox, it's automatically enforced. So let's lock in the key ideas here. First, the old ways of testing are broken for distributed systems. It's time to let them go. Second, treat your testing like a financial portfolio. The goal is to maximize confidence, not just the number of tests you run. Third, contract testing is your new best friend. Seriously, it should be the backbone of your entire quality strategy. Fourth, you have to extend your validation into production. Use Canaries and observability to test where it really matters. And finally, automate all of these layers in your CI/CD pipeline. That's how you build quality gates that let you ship with both incredible speed and unshakable confidence. And I'll just leave you with this one last question to chew on. If your fancy, expensive monitoring and observability tools can spot a failure happening in production, why couldn't your testing strategy have stopped it from ever getting there in the first place?